Hello, and welcome back to the channel. Today, we're going to be continuing our exploration of the LangChain framework, and we're going to be going over one of the tutorials in the documentation. The tutorial we're going to be going over today is how to build a chatbot. If you haven't seen the previous video going over just how to build a simple LLM application, I encourage you to go ahead and check out that previous video because some of those concepts are going to be repeated in today's video. So let's dive right in. So today we're going to be building a chatbot. Overview. We'll go over an example of how to design and implement an LLM-powered chatbot. This chatbot will be able to have a conversation and remember previous interactions. Note that this chatbot that we will build will only use the language model to have a conversation. There are several other related concepts that you may be looking for. Conversational RAG, enable a chatbot experience over an external source of data, and agents, build a chatbot that can take actions. Cool, we're definitely going to be going over both of those in upcoming videos. This tutorial will cover the basics, which will be helpful for those two more advanced topics, but feel free to skip directly there should you choose. Setup, Jupyter Notebook. This guide, and most of the other guides in the documentation, uses Jupyter Notebooks and assumes the reader is as well. Jupyter Notebooks are perfect for learning how to work with LLM systems because oftentimes things can go wrong, unexpected output, API down, etc. And going through the guides in an interactive environment is a great way to better understand them. This and other tutorials are perhaps most conveniently run in a Jupyter Notebook. See here for instructions for how to install. Installation. To install LangChain, run pip install LangChain or conda install LangChain. I personally use conda to manage my Python environment, so I've already got LangChain installed in my conda workspace. Langsmith. Many of the applications you build with LangChain will contain multiple steps with multiple invocations of LLM calls. As these applications get more and more complex, it becomes crucial to be able to inspect exactly what is going on inside your chain or agent. The best way to do this is Langsmith. After you sign up at the link above, make sure to set your environment variables to start logging traces. So I've already signed up for a Langsmith account, and I have a Langsmith API key. And so let's get started. I'm going to copy this piece of code and move over to my Jupyter Notebook, which I already have running. And we're just going to go ahead and paste that in. So when we run this code, it's going to prompt us for our LangChain API key. So I'm going to go ahead and run this code, and I've got my LangChain API key right here. And we'll just go ahead and give that. Not now, last pass, thank you. Okay, quick start. First, let's learn how to use a language model by itself. LangChain supports many different language models that you can use interchangeably. Select the one you want to use below. Okay, so we're going to stick with the default open AI model. So in your Python environment, you're going to need to install the LangChain OpenAI package. And then I'm going to go ahead and copy this little piece of code here and go over to my Jupyter Notebook, paste that in. And actually, I think since this documentation was written, ChatGPT has come out with a new model. So I'm going to go ahead and just use ChatGPT-4 as my model instead of the 3.5. So when I run this, it's going to prompt me for my OpenAI API key. And let's go. Not now. Great. All right, let's use the first model directly. Chat models are instances of LangChain runnables, which means they expose a standard interface for interacting with them. To just simply call the model, we can pass in a list of messages to the invoke method. So from LangChain core.messages, import human message, and then model.invoke, and we're passing a human message whose content is, "Hi, I'm Bob." So we can imagine that, if we were building an application that was accepting, custom user input, for example, in a text box or through voice, the content would be the actual prompt by the user. So let's go ahead and copy this and go to our Jupyter Notebook and let's run. Awesome. So when we invoke the model with this message, "Hi, I'm Bob," the response we get back from ChatGPT is, "Hello, Bob. How can I assist you today?" Cool. Awesome. And then, of course, we have a lot of metadata around this. How many tokens it took, the run ID. Awesome. Okay. Yeah. This model on its own does not have any concept of state. For example, if you ask a follow-up question, such as, "What's my name?" what are we going to get? So we're going to call model.invoke, and now the content is going to be a question that's referring to something that we previously were doing in the conversation. Okay, cool. As an AI, I don't have access to personal data about individuals unless it has been shared with me in the course of our conversation. I'm designed to respect user privacy and confidentiality. Okay, so basically, we haven't created a way for this conversation agent to actually remember queries. It's basically just responding to each query individually, and that's why it doesn't remember the fact that I gave it a name here. Okay. So we can see that it doesn't take the previous conversation turn into context and cannot answer the question. This makes for a terrible chatbot experience, of course. To get around this, we need to pass the entire conversation history into the model. Let's see what happens when we do that. Okay, so from LangChain core messages, import AI message, and then model.invoke, and then we're going to pass in actually the entire history. So both the human message, the AI message, and then the next human message following up asking about the name. So let's see what happens if we run this. So let's paste and run. Okay, cool. So because the information containing my name is part of the context, now the AI model is actually able to respond. So let's see if we can switch it up. Let's do another one. So rather than just asking it what's my name, let's see how many letters are in my name. Let's go ahead and run that. Your name, Bob, has 3 letters. Very cool. I wonder. Let's see. Let's ask it another question. What about how popular is my name in the United States? I honestly have no idea what it's going to say. According to the United States Social Security Administration, the name Bob was very popular in the 1930s through the 1950s, often ranking in the top 60 male names. However, its popularity has declined since then. In recent decades, it's not among the top 1,000 male names used. However, Robert, from which Bob is often derived, has consistently ranked in the top 100 for over a century. Okay. This is awesome. ChatGPT is very cool. Okay. And yeah, absolutely. We get great responses now. So the basic idea underpinning a chatbot's ability to interact conversationally has to do with actually passing it the entire message history. So how do we best implement this? Message history. We can use a message history class to wrap our model and make it stateful. This will keep track of inputs and outputs of the model and store them in some data store. Future interactions will then load those messages and pass them into the chain as part of the input. Let's see how to use this. First, let's make sure to install LangChain Community, as we'll be using an integration in there to store message history. Okay, so in whatever Python environment you're using, you're going to want to install this LangChain Community package. I've already installed it in my Conda workspace, so I have access to it in the Jupyter Notebook. After that, we can import the relevant classes and set up our chain, which wraps the model and adds in this message history. A key part here is the function we pass into the get session history. This function is expected to take in a session ID and return a message history object. This session ID is used to distinguish between separate conversations and should be passed in as part of the config when calling the new chain. We'll show you how to do that. Okay, so let's look at this code. From LangChain core.chat history, we're importing base chat message history, in-memory chat message history, and from LangChain core runnables.history, we're importing a runnable with message history. We're creating a store, and we're defining a function. This function takes in a session ID as a parameter and returns base chat message history. If session ID not in store, so if we don't already have a session ID in the store, then we create an entry, store sub session ID is equal to in-memory chat message history, return store sub session ID. And then we're creating a with message history variable, and that's equal to runnable with message history. We're passing in the model, and we're passing in this function get session history. Cool. We now need to create a config that we pass into the runnable every time. This config contains information that is not part of the input directly, but is still useful. In this case, we want to include a session ID. Config is equal to configurable, and then the session ID is equal to ABC2. Okay, so let's get this in our Jupyter Notebook. All right, that's gonna run, and then we need the config, and then we're gonna create a response object. Response equals with message history dot invoke with human message, hi, I'm Bob. Config equals config. And then the response dot content, it looks like it's actually gonna be the AI response. Okay, so let's get this and let's run this. Cool. Okay, so rather than just invoking the model directly with messages, which is what we did before, now we've created a config and we're actually invoking a runnable with the message history. Okay, cool. I think I follow. And then let's add in another message now. Response, and now the message is gonna be what's my name. So we're gonna actually refer to information that's been previously had in the conversation. And now, since we are actually storing information about each session individually, the AI agent should be able to actually respond correctly. So if we run this bit of code, awesome. So now it knows in separate conversations, right? We passed in separate messages, but with the same config, which has the same session ID. So it knows to refer to that previous bit of information. Great. Our chatbot now remembers things about us. If we change the config to reference a different session ID, we can see that it starts the conversation fresh. So if we were to change the config to now have a different session ID, so ABC3 instead of ABC2, and we try to start a conversation off by asking it, what's my name? Yeah, it's not gonna know because in this session, we've never actually given it a name. So yeah, that totally makes sense. So let's test this out. If we create a new config, and in this config, we pass in a different session ID, it shouldn't know what our name is because we've never told it our name in the context of this particular session. Yeah, cool. As an artificial intelligence, I don't have access to personal data about individuals unless it has been shared with me in the course of our conversation. I'm designed to respect user privacy and confidentiality. Cool. But if we actually use this new config and we pass in a response. Let's see. No. I'm not going to do that here. I'm just going to keep this the way that it is. But let's say that I actually said, my name is Joseph. Respond content. Let's run that. Okay. And then with the same config, now we're going to ask it what my name is. What is my name? And I'm expecting that it should know that my name is Joseph because I've given it that information within the context of this. Very cool. Very, very, very cool. And you know what? Just to see, I'm going to ask it that same question that I asked it before. How popular is my name in France? Why not? Let's see. I actually don't know if it's going to have an answer. Ooh. In France, the name Joseph might not be as popular as in some other countries. It's a classic name, and while it's not currently one of the most commonly given names, it does have a long history of use in France. However, popularity can vary greatly from year to year and place to place, so it's always good to check a local source for the most accurate information. Wow, this is very, very, very cool. Okay, so, yeah, so what we've done is we've proven the fact that if we pass in a different session ID, then it's not gonna remember, right? However, we can always go back to the original conversation since we're persisting it in a database. So if I switch the session ID back to the original conversation, so if I go back here and the config, and we're using ABC2, now it should know, now we're back to the conversation with Bob. Okay, cool. So I think this is how we would go about like creating a chatbot that can talk to multiple people, right? Each individual user of the chatbot, their conversation would have a separate session ID, which would allow the chatbot to actually be able to remember conversations with each of its users without actually having to have like one large database that has everybody's conversations. Very, very cool. Yeah, this is how we can support a chatbot having conversations with many users, for sure. Right now, all we've done is add a simple persistence layer around the model. We can start to make it more complicated and personalized by adding in a prompt template. Prompt templates. Prompt templates help to turn raw user information into a format that the LLM can work with. In this case, the raw user input is just a message, which we are passing to the LLM. Let's now make that a little bit more complicated. First, let's add in a system message with some custom instructions, but still taking the message as input. Next, we'll add in more input besides just the messages. So first, let's add in a system message. To do this, we will create a chat prompt template. We will utilize messages placeholder to pass all the messages in. So let's look at this bit of code. From LangChain core.prompts, import a chat prompt template and a messages placeholder. The prompt is equal to the chat prompt template.fromMessages, and we're passing in a system message. You are a helpful assistant. Answer all questions to the best of your ability. And a messages placeholder, and we're passing in the messages. And then we're creating a chain using the pipe operator of the LangChain expression language. So chain is equal to prompt pipe model. Okay, so let's get this in our Jupyter notebook. And let's run that. Okay. Note that this slightly changes the input type. Rather than pass in a list of messages, we are now passing in a dictionary with a messages key that contains a list of messages. Okay, yeah, for sure. So the response is going to equal chain.invoke, and then this messages is going to contain a human message. Hi, I'm Bob. Okay, so rather than invoking the model directly with model.invoke or invoking the model indirectly with the runnables, right? With message history.invoke, we're going to do a different invoke. We're going to call invoke on the chain itself. Okay. So let's do that. Invoke on the chain itself. I'm going to run this cell. Okay. So we're back at being able to actually talk to the assistant. Okay. We can now wrap this in the same messages history object as before. So with message history, but now we're using the chain and we're passing in that get session history function that we defined above. And then we're going to create a new config object with a new session ID. So this is going to be a session with ID ABC5. And now we're going to do another message now. So now we're going to go back to using the invoke method on the with message history object. And it looks like we're called Jim now. Excellent. Okay. So, excellent. Okay. Let's keep going. So now, if we ask it information in this particular session about the name, yeah, exactly. We've got a stateful conversation happening. Awesome. Let's now make our prompt a little bit more complicated. Let's assume that the prompt template now looks something like this. So you're a helpful AI assistant, answer all questions to the best of your ability in language. Okay, so cool. So we're actually going to make a slight change to the system prompt, and now it's going to answer in a different language than the one that we're prompting it in. That's pretty cool. So let's run that. And now, note that we have added a new language input to the prompt. We can now invoke the chain and pass in a language of our choice. So we're going to invoke the chain, and we're going to use Spanish as the language here. So let's go ahead and do that. Oh, very cool. Hola, Bob. ¿Cómo puedo ayudarte hoy? All right, well, let's see what happens if we do French. Bonjour, Bob. Comment puis-je vous aider aujourd'hui? What about Japanese? Awesome. I'm going to assume that that's what that says in Japanese. What about Chinese? Very cool. Farsi? Dude, this is awesome. What about Arabic? Yep. Hebrew? This is just fun. Sorry, I'm gonna stop doing this. Oh, dude, this is so cool. So basically, you can have your chatbot respond in any language that you want, and we can imagine having this be like a user configurable setting pretty easily, right? So your user could decide, in what language they want to both prompt the model and receive output from the model. Very cool. Let's now wrap this more complicated chain in a message history class. This time, because there are multiple keys in the input, we need to specify the correct key to use to save the chat history. Yeah, because there's a messages key and there's a language key, so yeah, for sure. So with message history is equal to this. Let's run that. We're going to make a new config with a new session ID. So this is going to start a totally new conversation. And we're going to add in another conversation. We're going to say, hi, I'm Todd. And now it knows to respond with Todd. And let's say French. Very cool. And then let's ask it about something that we've already asked it. So we've shared the name with it. It should know that my name is Todd in this conversation. Yeah, votre nom est Todd. Yep, awesome. This is very, very, very cool. All right, so managing conversation history. One important concept to understand when building chatbots is how to manage conversation history. If left unmanaged, the list of messages will grow unbounded and potentially overflow the context window of the LLM. Therefore, it is important to add a step that limits the size of the messages you are passing in. Importantly, you'll want to do this before the prompt template, but after you load previous messages from message history. We can do this by adding a simple step in front of the prompt that modifies the messages key appropriately, then wrap that new chain in the message history class. LangChain comes with a few built-in helpers for managing a list of messages. In this case, we'll use the trim messages helper to reduce how many messages we're sending into the model. The trimmer allows us to specify how many tokens we want to keep, along with other parameters, like if we want to always keep the system message and whether to allow partial messages. So let's look at this bit of code. From LangChain core messages, we're going to import system message and trim messages. We're going to create a new object trimmer by calling the trim messages function. Max tokens equals 65, strategy equals last, token counter equals model, include system equals true, allow partial equals false, and start on human. And then we're going to create a bunch of messages. So we've got the system message, and then alternating human messages and AI messages back and forth. And then we're going to invoke trimmer.invoke with messages. And that's going to return to us a trimmed version of the messages. So it has the system message, but it doesn't have any of the conversation above, the what's 2 plus 2. Okay. Yeah, for sure. I mean, it makes total sense, right? If our user is chatting with the agent all day, then, the chatbots have, intrinsic limitations of how much context they can have. And so therefore it definitely makes sense to, use some type of trimming system. So let's get this in the Jupyter notebook. Yep, okay, we got the same output that we see here in the docs. To use it in our chain, we just need to run the trimmer before we pass the messages input to our prompt. Now, if we try asking the model for a name, it won't know since we trimmed that part of the chat history. So from operator import item getter, from LangChain core runnables, import runnable pass-through, and then chain equals runnable pass-through dot assign messages equals item getter with messages, pipe trimmer, pipe prompt, pipe model. And then the response equals chain dot invoke with the messages. So all the previous messages plus the new message. So the previous messages, but having been trimmed, and then in English. So let's go ahead and run this. So what we're expecting is that the agent doesn't know what our name is because we've trimmed that part of the, yeah, exactly. Since we've trimmed the part of the conversation that includes the part where we tell it our name, it doesn't know the name. However, I'm pretty sure. Yeah. But if we ask information that is within the last few messages, it remembers. So if we were to ask it a message about the math problem that we asked, right? What math problem did I ask? It definitely should know that because that's part of the trimmed messages. Yeah, exactly. Let's now wrap this in message history. So with message history equals runnable with message history, chain, get session history, input messages, key equals messages, and we're creating a new config. So now we're creating another session ID. So this is going to be a new conversation. And if we ask it what our name is, it doesn't know, right? So actually, let's just run this and run that. Yeah, exactly. As expected, the first message where we stated our name has been trimmed. Plus, there's now 2 new messages in the chat history, our latest question and the latest response. That means that even more information that used to be accessible in our conversation history is no longer available. In this case, our initial math question has been trimmed from the history as well, so the model no longer knows about it. So once again, if we ask it about the math problem here, it's not going to know because we've trimmed that message from the messages. Yeah, for sure. Very, very, very cool. Okay, so streaming. Now we've got a functioning chatbot. However, one really important user experience UX consideration for a chatbot application is streaming. LLMs can sometimes take a while to respond. And so in order to improve the user experience, one thing that most applications do is stream back each token as it's generated. This allows the user to see progress. And it's actually super easy to do this. All chains expose a .stream method, and ones that use message history are no different. We can simply use that method to get back a streaming response. So let's create a new config, and then we're gonna loop. So for our in with message history.stream, we're gonna pass in a message, hi, I'm Todd, tell me a joke. And then we're gonna print each response as it comes back. So basically, rather than waiting for the entire response to come back and then showing that at the end, we're basically gonna show each token that we receive back from the API as it comes back. So let's go ahead and do that. Oh, nope, I've actually gotta paste it in. And then we're gonna run. Okay, very cool. So as you can see, every individual token is being streamed right to our output. And let's just see what the joke is, right? Hi, Todd. Sure, here's a joke for you. Why don't scientists trust atoms? Because they make up everything. Well, that's a dad joke. I didn't know ChatGPT was the dad. But yeah, there you have it, guys. Building a functioning chatbot using LangChain. So next steps. Now that you understand the basics of how to create a chatbot in LangChain, some more advanced tutorials you may be interested are conversational RAG, enable a chatbot experience over an external source of data, and agents build a chatbot that can take actions. And if you want to dive deeper on specifics, some things worth checking out are streaming. Streaming is crucial for chat applications. How to add message history for a deeper dive into all things related to message history, and how to manage large message history, more techniques for managing a large chat history. Yeah, so guys, stay tuned to the channel because we will definitely be going over all of these tutorials in the future. So there you have it, building your first chatbot using LangChain. I hope you guys liked the video, and I hope you guys have a great day.